Okay, so now let's do the derivation for the hyperbola centered at the origin. So just like we did with the ellipse, we set this up. So we've got f1, the first focus at negative c comma 0, the first vertex at negative a comma 0. We've got the origin, then we got vertex 2 at a comma 0 and focus 2 at c comma 0. We've got our point. So now we've got to first find the constant, right? Because we know that any point, if we take the distances, the difference in the distances along any point, at any point along the graph, it's going to be the same. It's going to be some positive constant. So it should be true. It's also true along the x-axis. So we'll just make V2 a point, right? It's a point on the graph. So let's use V2. The distance from F1 to V2 and the distance from F2 to V2, that difference will equal the same constant. So let's figure out what that constant is. Okay, so D1 is just going to be C plus A, right? The distance from F1 to the origin is C, and the distance from the origin to V2 is A, so C plus A. And then distance 2 is going to be the distance. So here it's this distance here, but we don't know it directly. Okay? But we can find it by subtracting the larger distance to the focus, right? From the origin to the focus is C. And then we can subtract off the smaller distance here, which is the distance from the origin to the vertex, which is A. So if we take C minus A, that'll give us D2. So C minus A. And so, of course, D1 minus D2 is equal to C plus A minus C minus A, which is going to be C plus A minus C plus A. And so the C's cancel and we get 2A. And so now we know what the constant is, right? So that's why we did that. We wanted to find out what the constant is, that positive constant. So now we're going to set up for the general case, and we're going to now derive the equation. So now we're going to do D1 minus D2 equals 2A. So now this is going to be, now the distance formula, we're just going to use the distance formula between x, y, and the first focus, right? So that's going to be what? It's going to be y minus 0. Right? So it's going to be y minus 0, quantity squared, plus x minus a negative c, which is going to be just plus c. Okay? Then we're going to subtract the d2, which again is similarly done. So it's going to be y squared minus 0 squared plus the quantity x minus c quantity squared equals 2A. Okay, so now all we're going to do now is use algebra to kind of simplify this and use the property of roots. We're going to use what we've learned to solve equations with roots in them. Okay, so now I'm going to move this over. So this is going to give me y squared plus x plus c quantity squared, and that's going to equal 2a plus y squared plus x minus c quantity squared. Okay, so now I'm going to square both sides, and that's going to give me a squared plus the quantity x plus c quantity squared is equal to, now this is going to give me 4a squared plus 4a times y squared plus x minus c quantity squared, plus, now that's going to give me y squared plus x minus c quantity squared. So all I did was FOIL, or just squared both sides. So so all I did was square this side and squared this side, and so expanding this gives me this. Okay? Okay, so now what I'm going to do is I'm going to expand out. So this is going to give me y squared plus x squared plus 2xc plus c squared is equal to 4a squared plus 4a times the square root of y squared plus the quantity x minus c squared plus y squared plus, now I'm going to expand this out, x squared minus 2xc plus c squared. Okay, now notice that we have the equal sign, so y squared here is going to cancel with the y squared there. X squared here is going to cancel with the x squared here. The c squared here is going to cancel with the c squared here. And so lots of things cancel out. So let's rewrite this at the top here now that we don't need this. Okay, let's start it here. Now what do we get? We get, we've got a minus 2c here. So we're going to add 2xc, plus 2xc here. We're going to add plus 2xc here. So that's going to give us 4xc equals 4a squared plus 4a times the square root of y squared plus x minus c quantity squared. Okay, so now we're here. Now let's simplify this and solve it again because we've still got a radical in here. So this will give us 4xc minus 4a squared divided by 4a equals y squared plus x minus c squared. Okay. Again, make sure you pause the video if I'm going a little too fast or if there's steps I'm doing. Just if you don't know how I got from there to there, just pause and work it out. So now I'm going to factor out the 4 on the bottom to cancel with the 4 on the top. So that's going to leave me with xc minus a squared over a. And now I'm going to square both sides, right? Okay, so now I'm going to square both sides. And so that's going to give me what? It's going to give me the top squared, which is going to give me x squared c squared minus 2 a squared xc plus a to the 4th all over a squared, and that's going to equal y squared plus x minus c quantity squared. Okay, so I've got, just to recap, make sure I didn't make any mistakes. So x squared c squared minus 2 a squared xc plus a to the 4th. Okay, all over, and then that's right. Okay, so then now I'm going to multiply both sides by a squared. Okay, so that's going to give me this. Okay, so let's do this. So then I have x squared c squared minus 2a squared xc plus a to the 4th equals, now I'm going to get a squared y squared plus a squared times x minus c quantity squared. Okay, so now I'm going to expand this out again. So let's x squared c squared minus 2a squared xc plus a to the fourth equals a squared y squared. And then this is going to give me plus a squared times, this is going to be x squared minus 2xc plus c squared. And so now I'm going to simplify it, or simplify this. So x squared c squared minus 2a squared xc plus a to the fourth equals a squared y squared plus, now this gives me a squared x squared minus 2a squared xc plus a squared c squared. Now at this point here, these cancel, okay, and so now I end up with x squared c squared plus a to the fourth equals a squared y squared plus a squared x squared plus a squared c squared. Okay, so now I want to get c squared minus a squared as a term. Okay, so I've got a c squared here, and I've got an a squared here. So if I subtract both sides, if I subtract a squared x squared from both sides, okay, and then if I subtract a to the fourth from both sides, that'll do it. So then here, I'll get x squared c squared minus x squared a squared. So these will cancel here and here. And then that's going to equal a squared y squared plus a squared c squared minus a to the fourth and then what's going to happen is I can factor out the x squared here, so this will give me x squared times c squared minus a squared equals, and then I've got an a squared that I can factor out here, right? So the a to the fourth, so that'll give me a squared y squared plus, and then I can factor out an a squared, and that'll give me c squared minus a squared here. And now, here's the thing, now we know, okay, so we know that d1 minus d2 equals 2a, and we know that that is less than 2c, right? We know that that's less than 2c, right? We know because the distance a is less than this distance c, so 2a would be less than 2c, which implies that what? Well, it's kind of going backwards. We know that a is less than c, right? Just by the diagram. We know this distance is less than this distance, right? Okay, so we know that a is less than c. And then also that implies then if a is less than c, then guess what? If we subtract a from both sides, that means that c minus a is greater than 0, which then implies that c squared minus a squared also must be greater than 0. And so we're going to let b squared equal c squared minus a squared, right? So just like before, we're just going to let that be true. So we're going to just define that difference, that positive difference, as b squared. Now we're going to substitute in for b squared here. So now that gives us x squared b squared equals a squared y squared plus a squared b squared. Now what we're going to do is we're going to subtract a squared y squared from both sides, and we get x squared b squared minus a squared y squared is equal to a squared b squared. And now if we divide everything by a squared b squared, we are done, because that gives us what? Oops. The b's cancel here, the a's cancel here, and so we end up with x squared over a squared minus y squared over b squared is equal to 1. And that is the equation of a hyperbola centered at the origin.